Everyone, welcome back to the channel. If you are a student, you are a statistician, you are a researcher, or you are a student writing a project, a thesis, or a proposal, this video is very important to you. So I would like you to pay attention. Now, one common question students writing proposals or theses or statisticians assisting with proposal, one question they usually ask is, how many people should I include in my study? This is a very simple question that a lot of students usually ask themselves. How many people or how many participants, how many respondents should I include in my study? Now, today in this video, I'm going to teach you sample size determination. Okay, I'm going to take you through a step-by-step process using simple language, practical examples, and real life situations. Okay, so that by the end of this video, you'll be able to calculate your own sample size with confidence. You don't need to go and go and give your project to someone to do the sample size calculations for you. Okay, let's begin. Now, what is sample size? Or first of all, what is a sample? Or what is a sample size? What is a sample? Let's begin with the sample. Now, when we say a sample is basically a subset of a population that is selected to participate in a study. That is what we call a sample. Because you see, before you remember that before you do a study, you have what we call target population or study population. Now, one thing you should understand is that it's not all the group that meets your inclusion or your exclusion, okay, that would eventually qualify to be part of your study. Is that okay? Great. Eventually, those who will take part in the study is the sample. Okay, so when we say a sample is more like a subset of a population that is selected to participate in a study. That is what we call a sample. Now, but before you get that sample, you go through a certain process. The process is different for quantitative study and it's also different for qualitative studies. Okay, now so for example, if your population, let me give a practical example. If your population is all nurses, maybe you are doing a study, your population is all nurses in a particular hospital, okay, and you select 200 nurses to participate in the study, then the 200 is your sample size. Is that okay? That 200 nurses that you are selecting to partake in your study, that is the sample size. Now, why is sample size important in research? Why is sample size important in thesis, in project works? Why is sample size important? Now, sample size is important because, one, it ensures your findings represent the target population. That is one, and it's very important. Okay, two, it improves accuracy, reliability, and validity of your results. That is two. Now, the third point is that it helps you to manage time, cost, and resources, because you see, you can't use all the people that falls within your target population. At the end of the day, you need a sample, but the thing is that the sample that you are going to use should represent your population. Is that okay? Good. That representation is very important, okay, for the purpose of accuracy, reliability, and validity. Again, it's going to save you time, cost, and then resources. Because you see, if you want to use the whole target population, that would mean that you would have to spend a lot of time, and that will cost you a lot and may require that you use a lot of resources. Okay, again, sample size is important because it helps to prevent bias from using too small or too large sample size. Okay, again, it determines the statistical power to detect real effects. In simple terms, a small sample may give wrong conclusions. But then, you see, a sample that is not representative of your population too can give wrong conclusions. That is something you should learn in research. or in statistics. So a small sample may give wrong conclusions. And also, a very large sample may also waste time and money. But the interesting thing I want you to pay attention to is that a sample that is not representative of the target population or the population may also give wrong conclusions. That is even very, that is very dangerous. Is that okay? Great. So that is all that about sample size and then sample. Now, there are two common sample size formulas in research and in statistics. There are two very common sample size formulas. Now, the first one, let me talk about sample size formulas in quantitative study. Then we transition or we move into qualitative study. Now, for quantitative study, we have two common sample size formulas in quantitative studies. Two formulas that are commonly used in quantitative research or in quantitative studies. Now, the first one is the YAMANE'S formula, and then the second one is called the COCHRAN'S formula. Okay, so we have two in quantitative studies. There are two common sample size formulas. The first one is YAMANE'S formula, and then the second one is the COCHRAN'S formula. These are the two common sample size formulas in quantitative study. Now, let's look at them one by one. Let's begin with the YAMANE formula. Now, what is the YAMANE formula? The YAMANE formula states that N is equal to capital N all over 1 plus capital N into bracket E, close the bracket, raise the power 2. Let me go over it again. The YAMANE formula states that small n is equal to capital N all over 1 plus capital N into bracket E, close the bracket, raise the power 2, where small n is the required sample size, capital N is the total population, and the E is the margin of error, usually 0.05 for 95% confidence interval. Usually that is the significant level that we use, 0.05 for 95% confidence level. Okay, this is the formula. So this is what we call YAMANE'S formula. Small n is equal to capital N all over 1 plus capital N into bracket E, close the bracket, raise the power 2, where small n is the required sample size, capital N is the total population, E is the margin of error. Usually we use 95% confidence level with a significance of 0.05. Now, when do we use YAMANE'S formula? When? In what situation do we use YAMANE'S formula? Now, use YAMANE'S formula when the population size is known and fixed. This is the condition. We use the YAMANE formula when population size is known and fixed. So you want to do sample size calculation. You know the population size of your target population. The best formula to use is the YAMANE formula. Okay, but that is not the only condition. When we move on, I will give you several other conditions you have to consider. Okay, so you consider using the YAMANE'S formula when the population size is known and fixed. Okay, so for example, nurses in a hospital. You are going to do a study among nurses in a particular hospital, sometimes even a particular department within a hospital. If the population size is fixed, if you are sure of the population size of the nurses in that department or the hospital, the best formula to use is the YAMANE formula. Again, another example can be students in a school. You are going to do a study in a school among students or even among teachers. Okay, the best formula, if it is a quantitative study, the best formula to use is the YAMANE'S formula. But then you consider YAMANE formula when the population size is known, when you know the population size, or you can easily get access to the population size. Now, let's look at a last example. Pregnant women attending a specific clinic. It could be antenatal clinic or postnatal clinic. Yes, in such a situation, you are likely to get the population size. Okay, so in such a situation, you can consider using the YAMANE formula. So the condition is that we use the YAMANE'S formula when the the population size is known. Now, Another thing that you have to consider, another point you have to consider before you use Yamane's formula, when the population size is not so large. Because see, if the population size is very large and you still go ahead to use Yamane's formula, you end up getting a larger sample size. Okay, so you have to also consider that. But then the key point with considering Yamane's formula is when the population size is known. Okay, but the second point you have to also consider is if the population size is too large and you go ahead to use Yamane's formula, your sample size will be relatively very large. So you also have to consider that too sometimes when you are choosing sample size formulas. Okay, now let's look at practical examples. Let's work out some examples. Okay, so for example, you are going to do a study, maybe let's say among nurses, among students. You have a total population. You know the population. Let's say the population N is 500. So the population size for your target population, that is the capital N, that is 500. And let's say you want to use a confidence of, let's say, 95. Commonly, the confidence level we use when you want to do Yamane's formula is 95% confidence level. 95% confidence level. Okay, so with that, the margin of error or the significance will be 0.05. Then you put that in, you interpolate that into the formula. Okay, so we are going to have, the formula is, the Yamane's formula states that small n is equal to capital N all over 1 plus capital N, open the bracket, E, close the bracket, raise the power 2. Then you interpolate that into the formula. So here, our N is 500. So the capital N is 500. So N, small n is equal to 500 all over 1 plus 500. Open the bracket. The significant level is 0.05. So 0.05, close the bracket, raise the power 2. Okay, therefore, the N is equal to 500 all over 1 plus 500. Open the bracket. 0.0025, close the bracket. Is that okay? Great. So you solve, and at the end of the day, you get N is equal to what? 222. Now, one thing you have to pay attention over here is that you should be careful how you punch, or you go about the calculation, especially when you are using a calculator most especially with the numerator, so that you don't get the computation wrong. Sometimes students make that mistake. Okay, so you pay attention, do the inputs very well, and make sure the output you are getting, you confirm it severally, make sure the answer you are getting is very accurate. Okay, before you go ahead, because sometimes you see it will be very sad for you to use a wrong sample size to do an analysis, run everything, even go ahead with it, then later you come and realize that no, the sample size, the answer was wrong. No, so you always have to take your time and do the inputs very well. Okay, good. Now another example that you can try your hands is, let's say maybe you want to do a study to measure job satisfaction among hospital nurses. Let's say the total population of the nurses. Okay, the population size of the nurses in the hospital is 350 nurses. The common significant level that we use is 0.05. Then you interpolate that into the formula. So you are going to get small n is equal to 350 all over 1 plus 350 into bracket 0.05, close the bracket, raise the power 2. Then you do all your calculation. Then at the end of the day, you get the answer. Okay, then the final answer you get becomes the sample size. Now, another thing you have to pay attention to, there are times that you can do the calculation, then you get something like, let's say, 222.6. Now, what you should know is that the sample size usually should represent a finite number. So if you get something like 222.6, run it to a unit number, a whole. So 222.6 will be 223. For example, you do the calculation, you get 221.8. That will be 222. Okay, so always be very careful that when you do sample size calculation and you get a decimal number, try and run it to a whole number. For example, you do the calculation, you get 222.2. 0.2 does not go beyond 0.5. So that one, the answer will become 222. Is that okay? So that is also something you have to pay attention to. You always have to run if the answer you get, the final answer you get is in decimal, run it to the nearest whole number. Okay, that is also a very important thing you have to pay attention to. Okay, great. Now let's look at the second formula. The second formula is the COCHRAN'S formula. The COCHRAN'S formula for sample size determination. It's also one of the second common formula that is usually used by researchers or statisticians when they are writing their theses, proposals, manuscript, and all that. Now, the COCHRAN'S formula for sample size determination. Now, what does the formula say? Now, the COCHRAN'S formula is n, small n is equal to z squared multiplied by p into bracket 1 minus p all over d squared. Small n is equal to z squared multiplied by p into bracket 1 minus p, close the bracket, all over d squared, where small n is the sample size, z is equal to the z-score, and the z-score usually we use 95% confidence, and that would give us a z-score of 1.96. Now the p is equal to the estimated prevalence from a previous study. Now d is equal to the margin of error. Okay, the margin of error. Okay, let's go over the formula again. So the COCHRAN'S formula, small n is equal to z squared multiplied by p into bracket 1 minus p, close the bracket, all over d squared, where small n is the sample size, z is equal to the z-score, close the bracket. The z-score, usually we use 95% confidence interval, and the z-score for 95% confidence interval is 1.96. Okay, now the p is the estimated prevalence from a previous study. The d is equal to the margin of error. Okay, great. Now let's go further. Now, when do we use the COCHRAN'S formula? When do we use the COCHRAN'S formula? Now, we use the COCHRAN'S formula when the population is large or unknown. So you see, I gave you one additional point when we were talking about the YAMANE'S formula, that we use YAMANE'S formula when you know the population size. But then I advise you that do not use the YAMANE'S formula when the population size is very large, because there are times that you know the population size, but the population size is very large, and because of that, the sample size would also be relatively very large. In such a situation, consider using the COCHRAN'S formula. So we use the COCHRAN'S formula when the population size is large or unknown. We use the COCHRAN'S formula when the population size is large or unknown. So in a situation where you want to do a quantitative study, you do not know the population size, you are not sure of the population size, please use the COCHRAN'S formula. Okay, now COCHRAN'S formula usage is very common when you want to do a study to assess knowledge, you want to do a study to assess attitudes, you want to do a study to assess prevalence, you want to do an epidemiological study. You know, the best formula to use is the COCHRAN'S formula. It's very simple. That's the best to use. Okay, and COCHRAN'S formula is very simple because you see, you are just going to use a proportion from a previous study that measured a variable that is within your study. Simple as that. That makes it very simple. Okay, so let's look at an example. For example, let's say you want to do a study. For example, if your study, you want to measure something like knowledge of nurses on infection prevention. Is that okay? Knowledge of nurses on infection prevention. That is something you want to measure in your study. Now you have to go and look for a previous study that they also measure the knowledge of nurses on infection prevention. The study necessarily shouldn't be done in the country or the setting where you want to do your own. It can be a study done anywhere in a different setting. Is that okay? Good. Then the proportion that they had for the knowledge, you use that same proportion. So for example, you want to do a study. One of the variables you want to measure, maybe as part of your study, you measure the knowledge of nurses regarding infection prevention and control. Go and look for another study where the researchers assess the knowledge of nurses on infection prevention and control. So for example, when you get a study like that, check their results. What was their results for the knowledge? If the knowledge, let's say they found that 50% of nurses were knowledgeable, then you take that proportion, the 50% that were knowledgeable, Okay, then you use that 50%. So 50% will be 50 divided by 100. Then you use that proportion and you go and interpolate it into the Cochran's formula to do your calculation. So for example, you are doing a study. One of the things you are measuring attitude of nurses towards infection prevention and control. Go and look for a study that they also measure the attitude of nurses on infection prevention and control. Okay, you look for a study. You look for a study that they measure the variable that you would also measure in your study. Then you take the proportion of their measurement and use it to represent the proportion in the Cochrane formula and use it to do your own calculation for sample size. Okay, so let's look at an example. All right, let's look at an example how we can use the Cochrane's formula. So you see, look at this example. A researcher wants to determine the sample size for a study on nurses' knowledge on hand hygiene. Now, what are we going to do? So a study like this, nurses' knowledge on hand hygiene, what we're going to do is that we're going to look for another research that has been done either in Ghana, in a different country. You don't necessarily have to get an article or a study done in your own country. It can be a different setting. Now, the focus is that get an article that measures the same variables that you have, that you want to measure in your study. So, for example, if your study, you want to measure knowledge, attitude, and practice, you have the opportunity to use a study that they measured knowledge. They measured either the attitude or they measured the practice. Then you use the proportion of their variable. So, if that study, they measured knowledge of nurses on hand hygiene, what was the proportion of nurses that practiced hand hygiene or that had good knowledge on hand hygiene? So if their proportion was, let's say, 50%, then use that 50%. That 50% will be your proportion. So it will be 50 divided by what? 100. That will give you 0.50. If it was so, for example, previous study found, you see this example, previous study found 65% of nurses had good knowledge. So you see, they use this proportion, and usually if you are doing Cochrane formula, you have to reference that paper. Okay, because you adopted the proportion from the P in the formula. You see, in the formula we have the P. P represents the proportion from the previous study. The P, it represents the proportion from the previous study. So for example, another example can be, let's say you are doing a study. One of the things you want to measure is prevalence. Is that okay? You want to measure prevalence. Let's say prevalence of, let's say, a certain disease. Now look for another study that they also measured prevalence. Then you go to their results section and check their prevalence, the percentage. The prevalence, was it 40%? Was it 30%? The moment you see the prevalence, then you pick that resource and convert it into a proportion. Then you use it, you interpolate it into the Cochrane's formula and use it to do your calculation for the sample size calculation. Just that in your description of the sample size determination, you have to reference that previous paper that you adopted their proportion. You have to reference that paper. Is that okay? In fact, the Cochrane's formula is one of the formulas I consider very simple to use. I like to use the Cochrane formula for sample size determination a lot. Okay, so that is it about the Cochrane formula for sample size determination. Okay, yes, so over here, there are a lot of papers over here that you can check. So for example, these papers, for example, these are articles that they use Cochrane's formula for sample size determination. These articles over here too, they use the YAMANE'S formula for sample size determination. You can reference these articles and check the style, how they made their presentations. Okay, now let's move on to sample size in qualitative research. So now we are going to talk about qualitative research. Okay, so the two formulas we discussed, the Cochrane formula, YAMANE'S formula, they are commonly used in quantitative studies. Okay, now let's talk about qualitative research. Okay, now unlike quantitative studies, qualitative research does not use formulas. Why? The reason is because qualitative research focuses on depth of understanding, not on numbers. Qualitative research, it focuses on depth of understanding, not numbers. Now, what are the key characteristics? The key characteristics is non-statistical, it's flexible and evolving, it uses purposive sampling, okay, and then it focuses on information richness. Okay, these are key characteristics of qualitative research. Non-statistical, flexible and evolving, it uses purposive sampling, and it focuses on information richness. Okay, now let's look at some typical sample sizes in different kinds of qualitative study. So for example, typical sample size is usually small and manageable. Most often, the sample size they consider usually 10 to 30 participants, depending on the study design. Okay, we have different types of qualitative study designs. We can have the phenomenology, we can have the case study, we can have the grounded theory, we can have the focus group. Okay, good. So if you are looking at the phenomenology, then 6 to 10 participants is fine. If you are doing a case study, 4 to 10 participants is good. If you are doing a grounded theory, usually 20 to 30 participants. If you are doing a focus group discussion, usually 6 to 12, 6 to 12 per group. Okay, now we have something we call data saturation, which is very important in qualitative study, and usually a lot of writers do not understand what data saturation means. Now, data saturation is reached in qualitative study when no new themes or ideas emerge during your interview. Because you see, in qualitative study, you do interviews. As you are doing interviews, when you get to a point that is like you are not getting any new information, the information people are giving you or your participants are giving you, it's like the already existing informations that you have. So then it means that you've gotten to data saturation. So when no new themes or ideas are emerging, you've gotten to data saturation. That is one. Now, when additional interviews provide no new insights, okay, that should tell you you've gotten to saturation. And this usually occurs between 10. Usually you are doing qualitative study. By the time you conduct 10 to about 30 interview about 10 to 30 participants, depending on the complexity of the topic, depending on the participant diversity, and depending on the depth of data that you want, you may reach saturation at a point. Now, once saturation is reached, data collection should be stopped in qualitative study. Is that okay? Once saturation is reached. So if you are asked that, okay, how do we conclude on sample size in qualitative study? When data saturation is reached, what is data saturation? Data saturation is when, during the conduct of an interview in qualitative study, no new themes or ideas emerge. Is that okay? So as you do additional interviews, no new insights, you are not coming by any new insight. That should tell you you've gotten to the ideas that you are getting. It's like you've had those ideas in the previous interviews. That should tell you you've reached data saturation. And most of the time, usually data saturation will occur by the time you interview 10 to about 30 participants, sometimes 10, sometimes 12 maximum, you've reached data saturation, depending on the complexity of the topic, the diversity of the participants, the depth of the data, okay, that you are, the subjects that you are dealing with. Is that okay? So that is it about data saturation. Okay, that is it about data saturation in research. Okay, so we have sample studies over here. These are qualitative studies, okay, and they try to describe sample size determination. Okay, so you can reference these articles and check out how they describe their sample size determination. Then you can learn new skills, pick up practical ideas from these samples. Okay, now finally, sample size ensures credible and valid research. Remember that the YAMANE'S formula is used when the population size is known. In a situation where you are sure and you know the population size, you shouldn't lie. You shouldn't lie. You should be sure of the population size either by going to the facility to go and ask the statistician, or getting the population size from credible sources, from the facility registry. Okay, you use the YAMANE'S formula when you are sure and confident of the population size. Apart from that, then you may have to use the COCHRAN'S formula. There are two reasons that you'd use to consider COCHRAN'S formula: when the population size is unknown, and secondly, when the population size is large. Okay, so you can have a situation where, fine, you know the population and you may want to consider YAMANE'S formula, but the population size is large. And once the population size is large, because of the nature of the YAMANE'S formula, the sample size would eventually be large. In such a situation, consider the COCHRAN'S formula. Is that okay? Now, however, for qualitative study, we rely on data saturation, not formulas. And in fact, I like this part a lot. Pay attention to this part. In qualitative study, we do not do sample size calculations. We rely on data saturation, not formulas. Now, remember to always justify your sample size clearly in the methodology section, meaning describe your sample size determination clearly. Let your readers understand, your audience understand how step by step, take us through step by step process, how you went about calculating your sample size. Is that okay? Whether you are doing a qualitative study or a quantitative study, let us know systematically within the methodology section how you calculated the study site. Okay. All right, so I think I'll end over here for sample size determination. If you found this video very helpful, do well to like the video, subscribe to the channel, and make sure you share the contents to your colleagues in other institutions who are, who need assistance with research, how to, calculate sample size and all that. Okay. If you are doing statistics, you have colleagues doing statistics in other schools, do well to share the content with them. Okay, I wish you guys all the best. Thank you for watching, and happy research and all the best. Bye bye.